Okay, I'm just going to use completing the square to actually factorise these. And these are a little bit different because in here we do have a sum of 4i. So the sum is actually imaginary. So if you start with z squared minus 6iz and you halve it, square it, add it. Okay, so half times 6i gives you 3i, square it, 3i squared, and you get minus 9. So it's going to be minus 9, okay? Now you've got to work out what do you add to actually give plus 7. So if we went minus 9 plus what gives you 7, it's going to be 7 plus 9, which is 16. So you're going to plus 16. So you now have this, which is a perfect square, plus you have this 16 here. So that's now going to go to z minus 3i squared, because that's what we added on, okay? And then that's going to be plus 16. Just rub this part out so I have a bit more room. Okay, so you write it as a perfect square, z minus 3i squared plus 16. Then it's z minus 3i squared minus 4i squared. So then it's z minus 3i minus 4i, z minus 3i plus 4i. So you end up with z minus 7i, z plus I. If you did it using the other method, the product is plus 7. The sum equals minus 6i. So therefore the 7 must be in terms of like something I, something I. The only things that multiply to give 7 is 7 and 1. You've got to get a minus 6 in the middle, so it'd have to be minus 7 plus 1 is minus 6i. So that would be z minus 7i, z plus I, which is the same thing. That one's just factorising. And this one here is using the completing the square method, the one above, this one. Okay. All right, so let's just look at one more example. So let's factorise z squared minus 12iz, and we'll go plus 13. Okay, so first of all, let's just use the completing the square method. So you halve that middle term, including the I, and square it. So that will be 12iz, and then add it. Okay, so it'll be 6i when you halve it and square it. Okay, and then we're trying to see what we have to add to make 13. Like those two things together have to be 13 to make sure that this and this like add up together. Okay, so you get z squared minus 12iz plus, now 6i all squared gives you minus 36. So it's minus 36 plus what will give you 13. So minus 36 plus what gives you 13. So if you go 13 plus 36, which is 49. So this is going to be z. So we're going to write this now as a perfect square. This one here. Okay, so it'll be z minus 6i. Oh, sorry, yeah. Z minus 6i squared. And then it's going to be plus, so what do we add on there? 49, so that's 49. Okay, so then that's z minus 6i squared. I'm going to write it as a difference of two squares. So it's a minus 7i and square it. So it's z minus 6i. And then that would be minus 7i. Then it's z minus 6i plus 7i. So it's z minus 13i, z plus I, because 6 plus 7 is I. Okay, now if I was going to do that like a quicker way and just factorise it, so if I was just factorising, it's harmonic. So the product equals 13 and the sum is minus 12i. So if you take 13, and you know that 13 and 1 multiply to give it, just put your I in there. You've got to try and make minus 12i. So it's minus 13 plus 1. And minus 13i plus 1i will be minus 13i squared, which gives you minus 13 times minus 1, which is plus 13, which matches the 13 in the question, the plus 13. So we have a sum. The sum is equal to minus 12i. What's this one? Oops, sorry. Didn't work. I'll just get another highlighter. Yeah, so that's the sum, gives you minus 12, and the sum here, which is minus 12i. So now we know that the two numbers would be z minus 13i and z plus I. That would be your numbers.